Welcome back. In this tutorial we will build a professional infrared BGA rework station from scratch for around $500. This tutorial consists of 3 parts. In this video I will explain which products I used, what the total costs are and how the wiring looks like. In part 2 the actual build of the BGA rework station will be shown. In the third and final part I will be focusing on calibration, setting up the rework profiles and removing the GPU from a graphics card. The affiliate links to the products I use can be found in the video description. By using these links to shop, you are directly supporting my channel at no extra cost to you. The rework station that I'm going to build is for medium and large PCB boards like motherboards, game consoles and graphic cards. The power consumption of this BGA rework station is between 1600 watts, that is when you have 2 bottom heaters on, and the maximum is 2800 watts, and that is when you have all 4 bottom heaters on. If you want to build a custom size rework station, that is also possible. It depends on which components and parts you need. Why do you need a good rework station for large PCB boards? Larger PCB boards tend to dissipate heat more efficiently due to their size and greater surface area. To ensure proper heat transfer to the solder joints, a higher rework temperature is necessary to overcome this heat dissipation and reach the required temperature at the solder joints. Larger PCB boards typically have more components and thicker copper traces, resulting in higher thermal mass. This means it takes more energy to heat up the entire board and reach the desired temperature at the solder joints. Depending on the type of solder that is used, larger PCBs may require higher temperature to reach the melting point of the solder. Lead-free solder, for example, typically has a higher melting point compared to lead-based solder. Achieving uniform heating across a large PCB can be challenging, especially in areas with dense components population or thicker copper layers. Larger PCB boards have more thermal stress during the rework process. Some components such as large BGAs or high-density connectors may require specific temperature profiles for successful rework. Additionally, preheating the PCB board can help optimize the rework process for large PCBs while minimizing the risk of thermal damage. I will use the infrared 6500 products to build this rework station. The IR6500 is an infrared rework station that's commonly used in the electronics manufacturing process and repair processes. It is designed for reflow soldering and rework of surface mount electronic components onto the PCB boards. These stations have precise temperature control and infrared heating elements to melt the solder and create a good solder joint between the components and the PCB. Building your own BGA rework station can be a cost-effective solution for those who have the technical expertise and resources to do so. Here are some reasons why someone might choose to build their own BGA rework station. Building your own rework station allows you to customize the station to your specific needs and requirements. Commercial BGA rework station can be expensive, especially those with advanced features. By building your own, you can save money and equipment costs, especially if you already have some of the necessary components or can source them at lower prices. Building a BGA rework station from scratch can be a valuable learning experience for hobbyists or professionals looking to expand their skills. It provides an opportunity to gain a deeper understanding of the underlying principles and components involved in BGA rework. A do-it-yourself rework station offers greater flexibility in terms of maintenance and repair. Since you build it yourself, you'll likely have a better understanding of how it works and can troubleshoot and repair it if there are any problems with it. Depending on your specific requirements, you can design your own rework station to meet certain specifications or standards that are important to you, like temperature control or compatibility with certain BGA sizes and types. However, it is essential to consider the challenges and the risks associated with building your own BGA rework station. Building a rework station requires a solid understanding of electronics and also some soldering techniques. Working with high temperatures and delicate electronic components can pose safety hazards because the power consumption of this BGA rework station is around 2800 watts. Proper safety precautions must be taken to prevent injury or damage to the equipment. Commercial rework stations are typically engineered and tested to meet certain quality and standards. Building your own station may not guarantee the same level of performance. especially if you lack the experience or do not have access to high quality components. Designing and assembling a BGA Rework Station from scratch can be time consuming and may require significant effort, especially if you encounter technical challenges along the way. If you decide to proceed, this walkthrough can help you with the research, planning and building your own custom infrared rework station. So let's start. I will list every product that we need to build this BGA Rework Station. First we need a computer case, and this is of the type HTPC. HT stands for Home Theater Case. HTPCs are computers designed to be used primarily for multimedia playback, such as streaming videos and watching movies and even gaming. The case is big enough to house the whole BGA Rework Station. That's why I choose this type of computer case. Then we need 4 hand knob tightening screws of type M5 10mm long. This hand knob tightening screw, I'll be using it for the support clamp. Then we need a circular electrical connector of type GX16. This has 4 pins. So we need this part of the connector, because this part will be connecting the upper heater. And this will be implemented in the case on the left side. Then we need 2 terminal blocks. And the terminal blocks are used to secure and connect electrical wires or components. And they provide a convenient way to organize electrical wiring within this case. This is a BGA support clamp, consists of 4 adjustable arms that can securely hold the PCB board in place, ensuring that it remains stationary during the rework process. And these 4 pins will hold the PCB board in place. Then we need a set of power switches, high current switches, and this is of a type 30 to 40 amps for 250 AC current. The first switch will be used as the main power switch. The second switch will be used to turn on the fan and this LED light. The third switch will be used to turn on the first 2 bottom heaters. The fourth switch will be used to turn on the third and the fourth bottom heater. The fifth switch will be used to start the BGA Rework program. It's the run function, and this run function will start the program that is in the temperature controller. This is 12 volt flexible LED light. This is the infrared upper heater. It has a power consumption of 450 watts. This upper heater will be located above the component that you want to reflow, like a BGA chip or a socket. And this upper heater will rise the temperature of the solder joint to a melting point. We need a PC410 temperature controller panel, so this is the brains of the whole operation. This temperature controller will control the upper heater and will also turn the bottom heater on. Then we have the REX-C100 temperature controller, and this temperature controller will control the 4 bottom heaters. Then we need 2 K-type thermocouple wire. A K-type thermocouple is a type of temperature sensor that consists of 2 different metal wires that are joined together at the end. One thermocouple will be used to measure the temperature of the PCB board on the top side, and the other one will be measuring the temperature on the bottom side. One thermocouple will be connected to the temperature controller PC410, and the other one will be connected to the REX-C100. Then we need 4 ceramic heating plates. Every heating plate has a power consumption of about 600 watts. The total consumption will be 2400 watts when all of these heating plates are on. This is a serial COM port. The ground connection, the transmit and read connection will be connected to this temperature controller. When you connect the cable to your computer, then you can read the temperature measurements from this controller to your PC. I will implement this functionality, but I will not use it. This is a circuit breaker or a RCCB. It's an electrical safety device designed to protect against electrical shocks and fire hazards caused by ground faults or shorts. It will disconnect the circuit when there is some kind of short on the line. I will be using the 64 amp version, and that is because we have a lot of power consumption when the top heater is on or the bottom heater is on, so it will be generating a lot of power, and that's why I choose the 64 amp version. Then we need a 3-wire electrical wire. Please use a high quality one because we are generating a lot of power. Then we need a connector terminal kit to provide the wire with a correct connector to connect it to the temperature controller, the solid state relay, the power supplies, etc. We need 2 solid state relays of 50 amps. The basic operation of a solid state relay involves using a low power control signal that will be fed into pins 4 and 3, the minus and the plus. This control signal will turn on the switch in the solid state relay, so the high current can pass to pin 1 and then to output pin 2. With the solid state relay you can turn on and turn off the upper heater and the bottom heaters to disconnect them from the circuit. And this one is optional, it's a connector strip just to connect the wires to each other. Then we need a 12 volt power supply of 1 amps, and this power supply will convert the high current into 12 volts, and we need 12 volts to run the fans and the LED lights. The IR6500 upper heater will be connected on this monitor arm on this part, and this will be bolted on the case. We need 3 meters of aluminium profile 2020 extrusion. This extrusion will be used for the spacing between the bottom heaters and the PCB board. This extrusion will also be used to connect the BGA support clamp. To connect this aluminium profile together, we need 4 corner connections with screws for the 2020 aluminium profiles. Next we need 3 sets of 20 M4 standard drop-in T-slots. This T-slot drop-in, you can slide it into this profile and then you can screw a screw into it. We need a set of 50 Allen socket head screws of type M4 by 60 mm, and we also need a set of M4 by 10 mm. We need 8 SK8 rod mount, and this mount will be connected to the extrusion, and in the holes the metal rod will be inserted. This is a metal rod of 8 mm and the length is 1 meter. I also bought a set of M5 drop-in T-slots for the 2020 aluminum profiles. I also bought an extra set of fork spade connectors. These fork spade connectors will be used to connect the wires to the temperature controllers. I also bought 2 sockets of this K-type panel mount. It makes it easier to connect the thermocouple wire to the temperature controller by using this socket. These are M4 10mm aluminium flat washers. This is a M4 aluminium flat washer gaskets. It's also a spacer to have some extra space between the screw and the aluminium profile. To protect the wires from touching each other, I will be using also heat shrink between the connectors and the wires. I also bought a set of insulating male-female bullet shaped connectors, and I will be using them for the bottom heaters to connect the wires together. The total price of this BGA Rework Station depends on which products you can get on a second hand, or maybe you have to buy a new one, the materials and components that you already have. So let's say you don't have anything, then you can use this list with all the pricing for each product. Then you can estimate the total price of the BGA Rework Station that you want to build. The amount marked in red are the products that you definitely need to build this BGA station. And everything that is black is optional. It depends on what you already have and also the tools that you already own. So we definitely need a computer case. We need a GX16 rounded connector to connect the upper heater with the case. We need the BGA support clamp to clamp the PCB board. We need the high current switches. We need the flexible arm LED light. The upper heater is the most important part. That is the IR6500 infrared upper heater of 450 watts. It costs around $42. The brains of this operation is the PC410. You definitely need that one. It's around $55. For the bottom heater we need the REX-C100. It costs around $11. We need 2 thermocouples to measure the temperature from the bottom side and the upper side of the PCB board. It costs around $20. We need 4 bottom heating plates. A set costs around $52. We need to have a 64 amp circuit breaker to protect the whole circuit and the main power supply from short circuits. You need 4 meters of 3-wire electrical wire. Please choose a high quality one. It's around $3. You need 2 solid state relays, one to drive the upper heater and the second one to drive the bottom heaters. We also need 12 volt 1 amp power supply to provide power to the fans and also to provide power for the LED lights. We need a VESA monitor arm. I bought a second-hand one and it was around $26. This monitor arm will be used to connect the upper heater to the monitor case. The total price when you have a second-hand PC case and a second-hand monitor arm will be around 442 euros. And when you have to buy all the products new, it can be around 600 euros. Also, I made a mistake. All the pricing here is in euros. So pricing here is in euros and this is also in euros. And then you can convert it back to dollars, to pesos, to rupees, whatever currency you have. The PC410 temperature control consists of a control unit, temperature sensor such as a thermocouples and output relays or switches for controlling the heat and cooling elements. It allows users to set a desired temperature set point and maintain the actual temperature close to this set point by adjusting the output to the heating or cooling device. These controllers feature digital displays for easy monitoring of the current temperature and set point, as well buttons or interfaces for adjusting the settings. This is the front side of this temperature controller and this is the back side of the temperature controller. In part 3 we will dive deeper into this temperature controller, how to set it up, how to calibrate it and also doing some test runs. On the back side these are the terminal connections, so this is terminal 1 to 10 and this 11 till 20 and the wires will be connected to these terminals. The power supply will be connected to terminal 1 and 2. Terminal 4 and 5 will be the output of the solid state relay and the solid state relay will drive the heating element of the top heater. When you start a program, the output on terminal 6 and 7 will be switched on. This will switch on the bottom heater solid state relay of the bottom heater. Terminals 8, 9 and 10 will be used for the serial communication. Terminals 11 and 12 can be used to drive a output of a alarm. You can connect a LED or a buzzer. On terminals 13 and 15 you can connect a toggle switch and when you press this toggle switch it will stop the program. Between terminals 14 and 15 you can connect a switch and when you press this switch the program will start, so it will run the program. And last, on terminals 18 and 19 you can connect the thermocouple. Be aware that you have to connect the positive lead to the terminal number 18 and a negative lead to terminal 19. This is a temperature controller for the bottom heater, is the REX-C100. The REX-C100 is a digital temperature controller suitable for different applications where precise temperature control is required, such as industrial ovens, furnaces, incubators. In this case, it will be used as a preheater that will drive 2 or 4 ceramic heating plates for the bottom heater. This is the front side of this temperature controller, these are the buttons and this is the digital display. On the back side, on terminals 1 and 2 you will connect the main power supply. The solid state relay will be connected between terminals 3 and 4 and this solid state relay will drive the bottom heaters. It will drive the 4 ceramic heating plates. The thermocouple that will measure the temperature for the bottom heater will be connected to terminals 9 and 10. The negative lead will be connected to terminal 9 and the positive lead will be connected to terminal 10. Here you can see the wiring diagram for the BGA Rework Station. This is the main power supply. The ground lead is connected to the chassis ground, so that will be connected to the BGA Rework case. The phase line and the neutral line will go to the current circuit breaker, the RCCB, and the phase line will go to the main power switch. So if this switch is turned off, there will be no power going through the circuit. From the main switch there will be a connection to this terminal block, the phase terminal block, and it will power all those connections. The phase and neutral line will go to the temperature control, the PC4110, to power this temperature controller, and it will only power this up when this power switch is turned on. The same applies for the REX-C100 temperature controller. The neutral line and the phase line will power this temperature controller. It will also provide power to this 12 volt power supply. This 12 volt power supply will provide power to the 12 volt LED light, the top heater fan and the case fans. I've added a switch So the positive line will be connected to this switch, and when this switch is turned on, it will provide power to turn the LED lights and the fans on. On terminal 4, the positive side will be connected to the solid state relay on the positive side of the connection, and the negative side on terminal 5 will be connected to the negative side of the solid state relay. This solid state relay will drive the top heater, the IR6500. As you can see, the phase line will go to this relay. The neutral line will go directly to the top heater. When the program starts for this temperature controller, it will drive this solid state relay and it will switch this circuit on. So this circuit will provide power to the top heater. Terminal 4 and 5 is known as an output 1. Terminal 8, 9 and 10 is used for the serial communication. Terminal 8 is ground, terminal 9 is a transmit line, and terminal 10 is the read line. On terminal 13 and 15, the stop push button is connected. So when you press this stop button, the program will stop. Between terminals 14 and 15, there will be a switch, a run switch. And when the switch is turned on, it will run the temperature program, the BGA Rework profile. On terminal 18, the positive lead to the thermocouple will be connected, and terminal 19 will be the negative lead to the thermocouple. This thermocouple will measure the top temperature of the top heater. The C100 temperature controller, so terminal 1 and 2 is the power supply. Terminals 4 and 5 are used to drive the solid state relay, and when it's turned on, this solid state relay will turn on the bottom heaters 1, 2, 3 and 4. We only want to turn this solid state relay on when the PC410 temperature controller, the BGA Rework program, starts. The positive signal that comes from terminal 4 will go to the top heater temperature controller on terminal number 7. When the output 2 is switched on, it will go to terminal 6, and from there it will go to the positive side of this solid state relay. The negative lead will be connected directly to the solid state relay. Terminals 10 and 9 are connected to the thermocouple, so 10 is the positive side and 9 is the negative lead. The bottom thermocouple will measure the temperature underneath the PCB board. When the solid state relay is turned on and it has to drive the bottom heaters, so the phase line will go to this solid state relay, and when it's turned on, this power can go through these two switches. So one switch, when it's turned on, it will drive the bottom heater 1 and 2. When this switch is turned on, it will also turn on the bottom heaters 3 and 4. So when the bottom heater is turned on and this solid state relay is also turned on, the phase line will go through the solid state relay. It will go through these two switches, and from there it will provide power to the bottom heaters. In most cases, the bottom heater 1 and 2 is enough to reflow a BGA. But let's say you have a bigger PCB board, then you can turn on the bottom heaters 3 and 4. Also, this terminal 6 and 7 is known as output 2. Here you can see the wiring. This is the main power cord. The yellow line will go to the chassis ground. The blue neutral line will go to the main power switch. And if it's turned on, it will go through this circuit breaker. From the circuit breaker, it will go to the neutral block connection. Every connection is a neutral connection. And this neutral line will go to the temperature controller. It will go to the top heaters, the bottom heaters, and the 12-volt power supply. The brown phase line will also go to the circuit breaker. From the circuit breaker, it will go to this phase block connection. So every connection is a phase line. And from here, it will also go to the temperature control on pin 1, on the C100 on pin 2, to the solid state relay, to the solid state relay that will drive the bottom heater, and a 12-volt power supply. This is the wiring that I use for the bottom heater. The phase line will go to number 2 of the bottom heater. The neutral line will go to terminal 1 of the bottom heater. And from the block connection, the neutral line will go to all the bottom heaters' ceramic plates. The other phase line will go to the solid state relay, and it will be connected here. And on the other end, it will go to the two switches. And these two switches will drive the bottom heaters. So let's say this is the switch of bottom heater 1 and 2. When it's turned on, it will provide power to these two ceramic plates. And if this is also turned on, it will provide power to the bottom heater number 3 and 4. The negative line for the solid state relay will go to terminal 5 of this temperature controller, and the positive lead will go to the top heater on terminal 6. The thermocouple will be connected to terminal 9 and 10. This is the 12 volt power supply for the LED lights and the fan. From the block connection, the phase line will go to this power supply, the neutral line will also go to this power supply. The ground line will go to the fan. Will also go to the top heater fan, and it will also go to the LED light. The positive line will go to 2 switches. In my case, I only implemented 1 switch to drive the LED lights and the fans. But if you need to, you can also add a second switch to only drive the LED lights. This is the PC410 temperature controller. So this is the brains of the whole operation. In this temperature control, you can set up a BGA Rework profile. So on terminal 1 and 2, the power supply is coming in, the phase and the neutral line. Terminal 4 will go to the positive side of this solid state relay, and the negative line will go to this terminal. The phase line will also go to number 2 of the solid state relay, and when this relay is turned on, the phase line will go to the output of 1, and then it will go to the top heater. The neutral line is directly connected also to the top heater. When this solid state relay is turned on, the switch is turned on, so the top heater will start generating the heat. Terminal 8, 9 and 10 are used for the serial communication. Terminal 6 and 7 is the output 2. So terminal 6 will go to the solid state relay for the bottom heater plus connection. Terminal 7 will go to the bottom heater temperature controller on terminal 4. Terminal 7 from the PC4110 will be connected to terminal 4. And the terminal number 7 that comes from the PC410 will be connected to this positive side of the solid state relay. The thermocouple to measure the temperature on the top side of the PCB board will be connected here on terminals 18 and 19. 18 is the positive side and 19 is the negative side. The run switch will be connected to terminal 14 and 15. And the stop push button will be connected to terminal 15 and 13. This is the rework station that we're going to build in the next video. And these are the dimensions of the aluminium profiles. We need 4 aluminium profiles with a length of 34 centimeters that will be used on the right and the left side of this BGA Rework Station. Then we need 2 aluminium profiles with a length of 33 centimeters that will be used here and on the top side. Then we need 2 metal rods with a length of 37.5 centimeters. So that is this rod and this rod. The spacing between the bottom heater and the aluminium profile is around 1.5 centimeters. Spacing from the left side to the center of this bottom heater is 16.5 centimeters. The spacing between these 2 heaters is 2 centimeters. And the spacing between the left and the right aluminium profile is around 2.5 centimeters. This is bottom heater 1 and 2. And this is bottom heater 3 and 4. I also drilled some holes for the thermocouple holder. And the thread is M6. So these are M6 threads. The threads here for the LED lights is an M4 thread. This is the pinout of the G16 rounded connector. It's a 4-pin connector. And this is pin 1, 2, 3, 4. Pin 1 will provide 12 volts to the top heater fan. And pin 2 is the ground of this fan. Pin number 3 and 4 will deliver 220 AC current. Pin 3 is a neutral line. And pin 4 is a phase line. And this will provide power to the top heater. The top heater cable will be connected to this connector, and from here the power lines will go to the block connections and to the solid state relays. So this plug will be connected to this connector. In the next video I will show you the build process of this infrared BGA Rework Station. If you like this content and you want to see more, then don't forget to give a thumbs up and hit that subscribe button. Thank you for watching, until next time, bye bye.